Welcome to Lucene Revolution. All of us here who came this week to the Revolution, we are using search to some extent. We are either using it as a business, as a product offering, or we are using it as a search app for the users. And every time these users are using, every time they are leaving a trail of information behind, and whenever they are using these search apps, whenever they are using your search or your enterprise product, they are leaving all the information behind. So for example, when a user comes to your website and makes a search, they might click on the top one result, or they might click on the 5th result or the 10th result. And my question to you is, are we capturing all this information? Are we taking this feedback and improving our search based on it? So today, I'm going to talk about how we can use Fusion to do this. So basically, there are 3 things I want to talk today. First thing is, how can we capture events? How can we capture search events? Or how can we index these events within Fusion? And how can we use these events to display analytic reports so that our business users can make more sense of what's happening with the users and what they are doing? And then the third question is, how can we mix these search results in combination with the recommendations, in combination with the organic search results, so that we can generate recommendations or boosts on this? So first thing is, how are you going to collect events? So for example, you might have a user-facing website, or you might already be using Google Analytics, which is a hosted analytics system. But how can you collect your own events? You might have a website, and using this Snowplow.js tracker, you can embed this 15 lines of JavaScript code that will track every user event that is coming to your website. And it also lets you customize what events are sent to this website. So what it does is it gives you, for example, it gives you page views, page pings, how much time is user staying on your website, and how many users are they visiting, what result are you clicking. You can customize this JavaScript library to capture what search result are they clicking, what page are they on, are they clicking any of the panels that you want the user to see, etc. And this is a open source JS tracker done by Snowplow Enterprise Analytics. And we are going to use this, and whenever you use Snowplow to send events, Fusion is going to collect these events, and it's going to give you a dashboard type of information. So for example, this dashboard is generated on the raw signals that are sent by Snowplow, and we can see here all the different information. We can see how many number of users are coming to your website, and what's the time series, what's my peak usage, and how many times am I getting these events, and what is the time zone that the users are coming from, and what are the types of events are they clicking. Are they just staying on the website, or are they making purchases, or are they actually using search at all, or are they just adding to cart and then leaving the site? We can track all these things by using Snowplow, and it will help us capture events by default, and it'll let us customize events. And in combination with Snowplow and Fusion, you can start collecting events very fast and very quick. You don't need to write jQuery code to send events to like Fusion API or anything. What Snowplow does is it will let you configure, and it will let you send all the events, and it is compatible with your Google Analytics code that you have in your website right now. And then the next thing is, you all might already be collecting events already. You might have your own analytics system, or you might be tracking all the user events happening in the website, or on the search logs, or on the web server logs. And then the question is, how can you send these events to Fusion? Fusion has a very, very generic signals payload. All you need is a field type called type, and then you can customize these events, and you can add more properties based on your events. And events in general, they have a certain schema, but all these events vary so much, and all of them have they don't have a very fixed schema. And we wanted to provide users an example of how you can do this, how you can send these signals to Fusion, and how you can send all your additional information. So what happens is, whenever someone sends these payloads to Fusion, it goes through the signal service, it transforms the JSON event, and it stores here. First, let me talk about the 3 collections here. Let's say test is your catalog collection here, and then whenever you have a catalog collection, whenever you create one, we create 2 and 3 more catalog collections. One is a signals collection, and one is an aggregation collection. And whenever you send payloads to us, we store all that information back into Solr. We don't process them right away, or we don't do anything. So we take the event, transform it, and store it back in Solr collection, test_signals. And all this raw information that we are storing right now, we're going to use this in the future to make analytics or to mix with our search results. So here is an example of a page view signal. Here the mandatory field types are type and timestamp, And params is a very generic map object that you can add any events to. Here, it's as simple as user came to this website and he clicked on this URL at this point of time. On the left side, you see the input signal that is sent to the API. On the right side, you see the Solr document that is actually indexed. We transform this document and then we index this. And this is another example of customizable event. So here we have a very simple event, which is URL. And here what we have is you can add as much information as you want. You can send your user ID, you can send your page, or you can send your IP address or your user location so that you can use all of this information later. So the idea here is you collect as much information as you can. You send all that information to Fusion, and Fusion will store it in Solr for you. It transforms the event, and then it stores all this information. And anyone who is comfortable with Solr, they can use this information as type of general analytics, analytics and dashboards, but all of this is still raw information. So for example, you have thousands and 10,000s of users coming to your website every day, and you're going to collect millions of these events. And whenever you make a query, it takes time to make a raw query. And we're going to look at next, how can we use aggregations to do this? Aggregations to transform all these raw events. And this is an example of a click signal. So what is a click signal? So user comes to your website, he makes a search, and then he clicks on one of your documents. It might be your first document, or it might be your 10th document. And so that's what the left side payload tells us. So user made a search called Madden 12, and then he clicked on the document ID. And all other additional information is that it is an example of what you can capture. So you can add your user ID there. You can add the user ID. You can add the position that the user clicked it on, and the filter queries. And what filter queries? So for example, user made a query called iPad. Instead of clicking on the top 10 results, he went to the accessories. He clicked on the accessories first, and then he made a search again, and then he selected one of your results. And this is how we transform your event. We transform this back into Solr, and we store it as a Solr document first. Now that we have all this raw information, let's see what we can do with it. How can we use this raw information? How can we use all this raw information, and then how can we aggregate all this raw information? So for example, aggregations is a service inside Fusion that takes the raw signals from the raw signals collection, and it uses Spark for all the processing. So here what happens is, whenever someone submits an aggregation job can be submitted manually or via scheduler. So you can schedule these jobs to go through like once a week or once a day or half a day. And then whenever a job kicks in, what happens is we will submit the job to Spark for processing. This is our latest inclusion in 2.1. All the aggregation jobs that happen, they go through Spark. All the processing happens in Spark. So what happens is whenever something is submitted to Spark, using Spark Solr, we read the data from actual Solr collections. And then after processing data, we store it back in the aggregation collection. So the test underscore signals will always be our raw information. And then the test underscore signals underscore AGGR will always be our aggregated signals collection. So let's go through some of the examples now. So what can you do with aggregations? So for example, there are 3 types of aggregations that you can do. By default, we provide 3 types. One is simple aggregations, one is clickstream aggregations, and third is event miner aggregations. Using event miner aggregations, you can build user graphs based on this. So let's look at one example first. What I have here is, I don't know if everyone can see, but on the left side, we have 5 events, 5 rating events that happen. And everything is it's a rating made by users. So let's say we have 5 ratings, and then all these ratings are different values. And then I'm sending an extra payload called source. Now I send this to the Signals API. And then once I send this to the Signals API, it will get stored back in test signals collections, as we discussed. And then the next thing that happens is, now I have this raw information in test signals. I'm going to run my aggregation. So what's my aggregation definition? I'm going to do a simple aggregation. I'm going to take all my 5 events, and I want to calculate mean, standard deviance, and then the top K of each rating. And so what happens is I write my JSON aggregation definition, or I submit an aggregation definition via the UI. And then what happens is it goes through the aggregation service, and aggregation service in turn, it submits the job to Spark. And then once it submits the job to Spark, it will read the data from the raw collection, and then it will transform the event and store it back in aggregated collection. So for this example, let's see what the resulting document is. So here, this is our resulting document. As you see, this Solr, this is a final document that ends up in Solr. So we have the job ID, we have the type of aggregation that we just did, and we have extra information called timestamp and count. Count represents how many raw events are aggregated into this event. So in our example, it's 5, and then the grouping key is here, the params source. And then I have different values. Based on my computations, what I have is I have different values based on my aggregation definition that I have defined here. And we have 10 or 20 aggregation definitions that you can do on your own, just for exploring the data, for numerical data, for strings data. You can do things like you can split things, or you can do regexes. And once you define your aggregation, you can keep running your job manually or through a scheduler. And once you have that, you have all these events stored in the aggregated collection. Now let's see an example of click aggregation, what really happens here. So this is so here I simplified the diagram a bit, and here what I have is I have raw events, and I have my final transformed event. So on the left, what I have is I have 4 events. They are of type click, and all of those events have 2 fields. One is a query and a document ID. What is the query that user made, and what is the document ID that they ended up clicking? Now we take these events, and then we submit them to Signals API, and then once we aggregate them, these are the 3 resulting documents. So for example, on the left side, we have 2 documents that have the same query and same document ID. So we take these 2, and then we have one, and we result in one aggregation document, which is the second one. And we add, and as you see, there is a wait for all these events. So whenever you're doing a click aggregation, what happens is we do a time decay. We calculate a time decay based on when the source event happened, and then we calculate the resulting final wait value. So here, as you see, first 3 events happened in 2014, the last event happened in 2015, and you can see the difference between weights. The first 2 aggregated documents have very low weight, and then the final document has, it's given more weightage, it's given more priority because it happened more recently. And you can customize this. You can customize how time decay happens or what kind of time decay. For example, some use cases, you might want to have more time decay. Or you might, some events like news, you want very high time decay. So you don't want articles from last week to appear in your search results. You want articles happening just now, or happening for the past 1 week or past 1 month to appear in your search results. Now that we have aggregations, now the question is, how can I use these aggregations? How can I mix them with my search results, and what can I do with them? So the question here is, we have a recommendation API that we provide for users. It will give you a document ID and weight for the queries that you have, or you can make it as generic as you can use these 3 stages and make the whole approach more generic. You can query Solr. So what really happens inside? How do you mix these results? How do you take events from one collection, and then how do you take the aggregated events and then mix them in your prime results? So what we have here is, I have a signals collection, and then I have an aggregated collection. And so let's say I have a user app that is making a catalog, that is making a query to my catalog test. And then let's say this query is sharp. And then when the query comes in, whenever the query is submitted to query pipelines, whenever the query comes in, it goes through a series of stages which are customizable and which are set by the user or your search admin. So what happens is, here I have a dummy stage called set params. It adds some request params to Solr request. So as you see here, the final stage I have is query Solr. So the final, we only query the catalog collection at the end of our pipeline. We don't query it before. All the stages before query Solr, what they do is they modify your search request. They modify your request, add more params to Solr, so that we can get different types of response behaviors. So here, what we before query Solr, what we have here is we have a stage called recommendation stages, And what these recommendation stages do is they go and query the aggregated collection. They go and query the aggregated collection, and then they make some processing, and then they do some processing based on algorithm basis. So, for example, you might want to get results, roll them up, and then add boost to it, or you might want to add more parameters to your Solr query. So, for example, for clickstream aggregations, what happens here is we will take these documents from aggregated collection, and then we calculate unique document IDs for that query, and then we take the weights for that query, and then we add boost params to Solr. And so before the request hits Solr, we are adding boost values to it, and then once the query hits Solr, those document IDs from the aggregated collection, they are boosted, and then the search results go back to the user. So what's an example here? How can I do this? How can I boost my document? So here, this is an example of Fusion Search UI. You can't see the header, but yeah, this is a Fusion Search UI, and here I'm comparing two results with two pipelines. So what are pipelines again? Pipelines are a series of stages using which you can modify your query at query time. And all of these stages and pipelines, they are configurable in the UI. You don't need to edit any files. We have a user interface that we provide to change all these pipelines and stages that are going on. So here I have a query Call of Duty. On the left side, I have my pure organic results, the top 3 results that are returned for the query Call of Duty here. And on the right side, what I have is I have the results mixed with recommendations. And using these results, so for example, as you see, these top 3 results that are boosted, they come from the aggregated collection. They come from all the user clicks that have taken place. So for example, let's say in this example here, user clicked on the Call of Duty Modern Warfare 3 more number of times. So this is even, these boosts, they are from all over the user base. This example, so we take all the clicks that happen all over our website, and then in a generic way, we add boosts based on those documents. And you might ask, what can I do with users? How can I make it more customizable per user? How can I do this? So what we need to do for that is we need to add user information for every user event that is sent. So once we have all that user information, then we can customize the aggregation behavior to aggregate events per user. And then we calculate, and then using the event miner aggregation, we can calculate a graph-based navigation on how these users are similar to each other. And once we have these results, we can generate recommendations based on how similar user profiles are. So for example, we can say these 2 user profiles are similar if they are making if they are making same searches and clicking on the similar type of and clicking on the same documents. If this happens often, if this happens, if this co-occurrence event happens more times, we can say both of them are related. And here, that's what we see in the result. So when we apply recommendations, the results on the left side, they either get demoted to the 4th to 10th positions, or they either get removed from the top 10 results. Now the next type of aggregation that we have is event miner aggregation. Yeah, and I just talked about event miner aggregation. What does it do? It takes all your raw data. So first thing it does is it assumes you have a user event associated with all of your events. So once you have user ID associated with all of your events, what this aggregation does is it will divide all your raw events into sessions, and then it will calculate, and then it generates a co-occurrence matrix for tuples. So for example, you might say, give me a co-occurrence matrix for all my for the tuple user ID, query, and document ID. And once we have a co-occurrence matrix, what we do is we store it back in Solr. We calculate the aggregations, and we store that custom payload back in Solr. And then once we construct the graph from this, and when user queries us for real time, so for example, we store the data back in aggregation collection, and when user comes, and then when he queries back, what happens is we will read the data from Solr, we will calculate a graph based on it, and then we will tell you how much similar are these users. and etc. So for this work is done by Francis at Lucidworks. He published a blog on the results and the quality of these results that this graph navigation generates. And here is an example of what the graph looks like. So for example, what I have here is the red nodes are the documents that users clicked. The purple nodes, the dark blue nodes are the queries users made. And then the yellow nodes are, the green nodes are my users. And then the yellow nodes are the sessions that we are dividing this to. So for example, so here what we see is we see different users making different types of queries, but they are clicking on the same document. And when we generate this graph, when we query the graph for more results, and then when we have more aggregated documents coming out, we can walk through the graph, and then we can generate results based on it. We can generate the recommendations based on this. Now, I would like to show you. I would like to go through a demo of how these events really get captured and how we can use Fusion to do all of this stuff. One second. I need to log into the Wi-Fi. This is the Fusion admin UI that we provide right now with our version 2.1. And here we can see I have different types of collections, and I have indexed some test data that we got from some of the competitions that happen. And when we have this test data, what happens is, so let's say I create my collection Best Buy. And then when I have this collection, when I create this collection Best Buy, we create auxiliary collections. We call these three as auxiliary collections. And what do we do exactly with these auxiliary collections? What we do is we take so for example, the logs here, it will log all the queries that are happening. So if I go here, if I click on this, and then if I see what's actually inside the document, what happened is, what it shows me here is when our user makes a search, he executes a search using query pipelines. We read all the query params that user has executed, and we take the response. We read few fields from the response, like, so these are all different params that user has. And here I see, okay, what are the total number of documents returned, and what is the total time that has taken place? And by storing this raw logs, what we can do is we can generate analytics based on this. So let me show you the relevant Banana dashboard. It's not loading for some reason, but so I'm going to show this screenshot for you. So what I'm showing here is, this is a Banana dashboard generated from from the user logs. So what are the top 10, by using the raw signals data, what we can calculate is, we can calculate the top 10 searches that took place, and we can calculate something like 0 results. What are my queries that are returning 0 results? And are we keeping track of this information? By storing all this, we can report to our business users and say, okay, users are searching for this query and we don't have any results for it. Or something is going on inside Solr that is giving me 0 results. And and also on the left side, we see the time series chart that's going on. So what's my peak hours? during the whole year, what's the time of the year that I'm seeing all this, that I'm seeing a big peak, and when should I tune my search server so that it responds better to all of this user data that's going on. Now let's go back to the Fusion UI. So we talked about the first auxiliary collection, which is logs. And what do we do with it? We store all our search logs in it, all our raw search logs. And then the next thing we have is we have two things called two collections with suffix underscore signals and underscore signals underscore AGGR. And within this collection, within the signals collection, we store all the raw signals that are sent by the user or that are sent by Snowplow. And then if I click on this now, if I change my query pipeline to Snowplow, here I can see different facets. So what I have here is I have 34 events that are sent to the Fusion Signals API. And on the left side, I can see the different types of events. So for example, PP means page pings, PV means page views, and then I can have different type of information, like what is the operating system that user is using, what is the browser, are they using Internet Explorer to make all these queries, or they are using Chrome or Firefox, and then with all this information, we can generate dashboards on it, and then we can aggregate this information. I can do an aggregation saying, give me the top 10 users, or give me the different time zones where people are coming from, where are they using, give me different time zones where I have a peak, and where I'm getting user data from, user traffic from, or give me, or divide all my users geographically and tell me what's the most frequent location from which users are visiting my site. We can generate all these events from here.
How's our pipeline? Is that a Fusion thing?
Yeah. So for example, I can show you in a second. So what I have here is Fusion has two types of pipelines here, and these pipelines can be done at query time. They can be done at index time. So what do they do at index time? When you send documents to Fusion, it goes through the pipeline that is configured, and then it will modify all your data. So for example, so if I'm sending some data to Fusion, what I can do is I can choose a stage from all of these stages available so that I can modify my data so that it fits to my needs more, and then I can add these stages and transform my document before it hits Solr. Similarly, we have query pipelines. What do query pipelines do? They modify your request. When our user makes a request, what happens is it comes to one of these pipelines. Every request has to go through a pipeline. It's either a default pipeline or a customizable pipeline. And what does the pipeline have? So a pipeline can have any one of these stages. So it can use a JDBC stage to get data from to join data, so that it can use a JDBC stage to get data from a remote source and then join the data to the request. Or it can use a recommendation boosting stage, or it can use a facet stage or a security trimming stage, and then different types of things. So like SMTP stage is added by Grant for sending alerts to users or emails to users based on the searches that are happening. You can configure your pipeline to say, okay, if this search is happening, send me an email or send me a pager duty, or let's say we can configure this pipeline to say, okay, if my search is getting 0 results, send me an email or send me a pager duty. Or you probably don't want to do that, but these are, so you can make this all customizable based on using the Fusion admin UI. So here in the Snowplow, what I have is I have a query Solr stage, which does a simple query to Solr. And before this, what I have is all I have done is I have added the facet params. I can show you 1 second. This is another one of our demos that we did from one of the catalog data. So what I have here is I have pure organic data, and that's coming straight from Solr. I have the catalog indexed in Solr. And whenever I make a search, all these results that are coming, they are coming back from Solr. So I made a generic search called tablet. And it's a key phrase that can be present in so many documents across so many categories. And how do we distinguish what we are presenting here is what the user wants to see? How can we make sure they are going to click on one of our search results whenever they make searches like this? So here, what happens when I click on this is it will change the pipeline that is being used in the background. And then once we change the pipeline, I'm going to get a different set of results. So this is all based on the user feedback that we indexed already. So we indexed some signals, and then we added a recommendation stage that will transform these results whenever people use a recommendation stage or any one of our pipelines that are configured. So finally, I want to leave you with, so signals is not the only thing that you want to drive your search results with, but it should be a major factor. It should be one of your big factors that contributes to your search results. You don't want to modify everything based on signals, based on what other people are clicking. Everyone doesn't want to see those results. So finally, we should give an option to user to see what other users are doing, what are they clicking on, and what are the popular items. And it should be one of your additions. It should not be your search results. It should be a thing that you add to search results to make them more relevant to the user. I can take any questions. I can take questions from here if anyone have any. This is my demo. Yeah, this is my presentation. Yes. At query time, so for example, as a user, as a customer, what you would do is you would query one of our APIs and ask for information, and this graph traversal happens within our product, and then we do the traversing for you, and you can tune the params on this graph traversal and get the results back. Yeah, Lucidworks Fusion. Yeah. This is just a demo visualization that we developed. This is like, we added an extra HTML to the out of the box to show how the graph might look like.
This part is really fascinating because I've drawn a graph to explain my problem and how I want to search through the space and identify. So if I search across cases and I have their human curated relationships, their solutions, and then I have a graph of those two things. Well, I can add in the products that are related to that and all kinds of other bits of information to tell me what products the customer has on top of what products they have, and then I can tie in clicks from the website, which is another thing.
Yeah.
And I can understand how to tie this into signals. It's very straightforward. I had the class yesterday which says use the Best Buy collection and then add in the click signals.
Yeah.
Okay, completely get that. Now, how does, just step through this one more time, a little slower, about how we, what you're doing in Fusion to get, how are you going from lots of different inputs into graph and neighborhoods and select an answer and then have the result?
Yeah, yeah, sure. So let's say we have user data, we have raw signals data, we have user events. So for example, we have user ID that is embedded with every signal. Now we configure the aggregation to do a event miner type aggregation. So what does it do is within the aggregation, we calculate co-occurrence. We divide all these users. We divide all this user data into sessions. So for example, it is a configured session window. And then we divide all this data into 10-minute session window or 1-hour session windows. And once we have all these sessions, we calculate a co-occurrence matrix. So this matrix, we are calculating a tuple. So for example, here you can do a co-occurrence matrix between user IDs and queries. what are the give me all the user IDs on the left, user ID and query on the left side and on the right side, and what are the things they are clicking on. So what we do here is we calculate a matrix, co-occurrence matrix. We save it back into the Solr as a customizable format. 1 second, I might have more slides that tells you this. So what we do here is we take all the events that are happening in the time series. We calculate a session window, and then once we have a session window, we calculate a co-occurrence matrix on this. Once we have the co-occurrence matrix, so what is an example of co-occurrence matrix? This can be, so this is just an example. This is not a signals example, but this is a general co-occurrence matrix example. And once we have the data that is present inside, we will, once we store all this information, we can get back the information using Solr. We can get, at query time, what we can do is we will get the information from the aggregated collection, generate a directed graph on this based on the things that we are interested in. So for example, we are interested in queries, or we are interested in similar queries. So users clicked on 2 documents, but they made similar queries. Or users clicked on 1 document, they made a query called sharp, they made a query called sharp TV, but they clicked on the same document. So we can by using this graph, Fusion, you can ask Fusion to give me the information and to give me like either the user co-occurrence or the ID co-occurrence. And then once we have the results, we generate the recommendations on it. So for example, this is a thing we store in Solr. So what do we store in Solr? This is the final document that ends up in Solr after all the calculation. And then these are the, and at the recommendation time, if you ask for a recommendation for a query, this is the result. This is the Solr result that we take, and then this is from where we will give you the results. If you'd like more information, I can let you talk to one of our engineers who more worked on this in detail. Thanks. Yep.
And this is very interesting, and you mentioned one point about delaying some of the signal. I mean,
decaying. Yeah.
So I was wondering, for things that are very freshness oriented, like news, or I'm working on job search, which jobs become like basically obsolete after some period. Does this still make sense to do this kind of aggregation, especially if it's very fresh?
I think it makes sense on doing this aggregation, and while doing the aggregation, you can configure your base time that is compared when the time decay is happening. And also, so for example, you might not want to do a rolling aggregation if you think your old events are not important. So for example, what do I mean by rolling aggregation? So suppose, let's say I have a 6-hour window during which I'm doing aggregations. So I do my aggregations for the 6-hour window, or let's say 1-week window. I do my aggregations once a week. And then once I have my old aggregations, the new aggregation that kicks in after 1 week, we can ask it to either roll events, which means take all the old aggregations and roll them with new data, or just discard old data and only take the new events that happened in the last 1 week. So what I want you to take is like, this is a framework that we developed that we hope to be fit for all different types of use cases. And it is highly customizable at every step. You can customize when the event goes into the aggregation, when the event is coming out, and all of this is customizable at every step. And also, since we have integrated with Spark in the last version, in our last version, not this. Yep, this one. This one. So since we have integrated with Spark, we want to provide in future so that people can execute their own algorithms on the raw signals data. So let's say I have some algorithms in Mahout that I want to execute, or that I have some machine learning algorithms in Spark MLlib that I want to use on the raw data. So in future versions of Fusion, you'll be able to take these algorithms from Spark and then execute on the raw data. So that so you can take all the traditional algorithms and apply your data on it. No, we ship with Spark. In the latest version, we shipped with the Spark 1.4.
So is there like a UI distribution where you like actually add like Spark workers and stuff like that? Or?
No, we are not. Yeah, we don't. Right now, we don't have any of that. So for example, we are not, well, there are two things, right? When we are shipping Spark as a basic example, but people, they might want to run their own clusters, or they might have their own clusters running. So currently we don't have a way of provisioning, give me more worker nodes. So what we have by default is we ship a Spark master in standalone mode, and we add a Spark worker, and we give you one default Spark worker. But there is no UI to add more Spark workers or anything. But you should be able to doable from the command line. So for example, since I have a master and a worker running, it's easy to spin up more workers based on the requirements. So yeah, we are storing it as a Solr document. We store it as a Solr document as a Cooccurrence matrix. We take the matrix and then.
Is the presumption that that graph is relatively static or relatively static within periods of aggregating your clicks or whatnot?
Yeah, well, it depends on how frequent are your aggregation schedule. Are you changing? Have you executed new aggregations in the meanwhile, or you can do something like you can separate your aggregation data. So you can make sure all the aggregations that happen, they don't change all the previous aggregated data that took place. The session is almost over, but the session is over actually. But I'll be available for questions all through the day if anyone has anything. Thank you.